All right, YouTube, today we're going to do a quick video. I've had a Whirlpool made dryer. This is actually a Kitchenaid dryer. Kitchenaid, Kenmore, Whirlpool. These are just your standard dryers. Let me move around here and show you just a regular standard dryer. But the complaint was that it wasn't heating, and I came in and found that the high limit had blown, and I stuck a new thermostat and a new high limit in, and the nice lady did a couple of loads of laundry, and it blew the thermal fuse. So I come back in and look at it. I measure the cycling thermostat. Cycling thermostat looks fine. I stick a new one in just to see, and no matter where you put it in the cycle, the thing never cuts the heater off. The heater runs continuously. So let me give you a quick idea of what it's doing. First off, I've got my meter set to ohms. I've got it set to sound, so it's going to make a sound. All right, first of all, here's the new element that we're putting in. Let me connect this. Here's the new element we're putting in. If we want to check continuity through the entire element, we just touch right here, and as you can hear, we have continuity. But we should not have continuity to any of the other metal. You know, if I touch anywhere on here other than the element, I have nothing, right? So I come up, let's bump up to the top one just to make sure. We're going to, hard to do this with one hand, clip on, and as you can see, there is no continuity here. So when you get over here, we're going to look at the old element. When you get to the old element, we're going to start with the bottom. So I'm going to connect to the bottom. Same element. You can see the element has been ridiculously hot. I don't have great lighting, but there you go. All right, so I'm connected to the bottom. I should have continuity through it. That is a normal condition there, but here's the not normal condition. If I touch the metal housing, so when I touch the housing, it's coming on automatically. So here we go. Let's bump up to the top one again. Up to the top. Notice I've got continuity there. That means that somewhere either one of these insulators has broken, one of these coils has actually touching metal somewhere. It could be on the back side, which we can't see real well. I didn't see it anywhere on the front side, but this heating element is bad. It's just absolutely bad. So what's happening is as soon as power is applied to one side, the heating element comes on. So the heating element sits here and runs. So now the cycling thermostat tries to turn it off. Well, it can't turn it off because that's assuming it can turn one of the legs of this off, and it can't do it because it's shorted in the ground. What we're going to do is we're going to replace it with the good one. But let me show you this good one more time. All right, here's how a good one should read. A good one should only read continuity through the coil, which it's doing perfectly. It should never read to the outside, and it does not. Just the opposite of this one. When we're on here, we touch that casing, it automatically comes up and gives us a reading, and it shouldn't. So this is how it's supposed to work, and this one is just bad, no matter how you cut it. No matter which item you test, one side or the other. So that means as long as power is applied to one terminal, it is completing the circuit to ground and bypassing all of the actual parts that should be turning the system off. Well, I hope this helps somebody. Again, standard Whirlpool dryer. This is nothing fancy. It's just a standard Whirlpool, Kenmore, Estate, Crosley, lots of different models. But anyhow, I hope this helps somebody. Thanks for joining me.